Hello everyone, hope you all are doing great. This is going to be second part of action potential. Okay, so in the last video we've studied till the green and the yellow graphs. Now we'll be studying mainly the pink graph, this one. Okay, before that, action potential according to books is divided into 7 steps or 7 stages. Okay, so first I want you to understand the graph, and then automatically you'll be able to answer how many at what point which step is there. Okay, so first of all, now you need to pay attention to the y and the x-axis. The y-axis is about the membrane potential, which is in millivolts, and the x-axis is time in milliseconds. Okay, सबसे पहले it was at the resting state. Okay, neuron was at the resting state. So first में the potential will be minus 70 millivolts. This is the first step. Now the stimulus should be strong enough कि minus 55 millivolts is reached, which is the threshold potential. If it is not reached, so you won't be able to see this graph only. Okay, so second is you have to reach the threshold potential, which is minus 55 millivolts. Next you will be seeing is okay, minus 55 millivolts is reached. Now sodium का influx ही हो रहा है. So now you will be mainly seeing the positive feedback of sodium happening. Now another important point is standard books have mentioned that okay, so यहाँ पे potassium was more, यहाँ पे sodium was more. Sodium influx is occurring in depolarization, right? ये minus 70 था. As you can see, positive हो रहा है. It's becoming positive. Minus 55 is becoming positive. Now this has a tendency to move towards plus 60 millivolts. This graph will be having a tendency to move towards plus 60, okay, somewhere here. Why? Because plus 60 millivolts is the equilibrium potential of sodium. But it wouldn't be able to reach there because there will be inactivation of gates happening at plus 30 millivolts. Sodium was showing positive feedback. But ऐसे तो depolarization will be continuing forever. So in order to stop that, we need to what we need to do is we have to cause the inactivation of gates. So plus 30 millivolts पे there will be inactivation of gates acting. Okay, so plus 60 millivolts isn't reached. Now, okay, so sodium has come inside. And now the potential has become plus 30 millivolts. But what will be the tendency of the membrane now? कि फिर से equilibrium पे जाते हैं, क्योंकि equilibrium condition is what everyone wants to achieve. Okay, equilibrium condition meaning resting membrane potential. So it will have a tendency to go back to minus 70 millivolts. तो वो कैसे होगा? अभी plus 30 है, तो minus 70 पे reach करने के लिए there should be potassium efflux happening. So yes, potassium efflux is happening. It's happening. Now comes a very important point. Do you remember that ये yellow वाला graph which I had explained? I had told कि as you can see there are gentle slopes. Yellow graph was about potassium permeability. मतलब potassium की permeability to the membrane is rising also slowly and it's going down also slowly. मतलब when potassium का efflux हो रहा है and membrane potential has come again to minus 70 millivolts के close, तो potassium was following negative feedback. मतलब once your work is done, it will shut down. Okay, it was going to shut down. But because potassium की permeability to the membrane, it will fall also slowly. मतलब यहाँ पे the signal is given कि potassium, now you have to close your gates. But because the permeability to the membrane is lost slowly, the potassium के gates, they are trying to get closed, but they will get closed at minus 90 millivolts. But what was our aim? We wanted to reach till minus 70 millivolts, but we have come now to minus 90 because potassium was too slow. Potassium gates were too slow. So now we have to come back to minus 70 millivolts. So how will we come back to minus 70 millivolts is due to, see, remember I had told कि कौन से channels function कर रहे हैं? Sodium voltage depolarization के time, potassium voltage repolarization के time, which were too slow. But now अभी this condition is known as hyperpolarization, this one. Ideally what should have had happened is यहाँ पे it should have been a full stop, but क्योंकि potassium channels are slow, it is going down also. So now अभी हमको -70 पे again we have to bring it back, meaning कि बहुत potassium का efflux हो गया है, तो ये -90 हो गया inside. So now we need to bring +20 millivolts के जितना positive charge again inside the cell. So how will it be restored is by sodium and potassium leaky channels. Okay, so sodium potassium leaky channels will cause the influx of these positive ions, and then -70 millivolts will be reached. Okay, so now I want you to pay attention. 7 steps are 7. Okay, first step was RMP, resting membrane potential. RMP के time पे, if you have seen my RMP का video, which were the channels active, those were your sodium leaky, potassium leaky and sodium potassium ATPase pump. Okay, next you are seeing is threshold reach हो गया, तभी ही action potential होगा, right? नहीं तो local potential यहाँ तक नहीं आया तो ग्राफ ही नहीं फॉर्म का. So next is threshold potential. इसमें भी कौन से चैनल से एक्टिव, दोज आर योर सोडियम वोल्टेज गेटेड, क्योंकि अभी एक्शन पोटेंशियल है स्टार्टेड, तो अभी ओनली वोल्टेज गेटेड चैनल्स विल बी एक्टिव, एक्सेप्ट यहाँ पे हाइपरपोलराइजेशन के टाइम पॉजिटिव फीडबैक हो रही है, देन यू कैन सी सो सोडियम वोल्टेज. देन व्हाट यू कैन सी इज एक्शन पोटेंशियल का पीक आ गया एंड टेंडेंसी वाज टू मूव टुवर्ड्स +60 millivolts, बट इट इज नॉट अचीव्ड बिकॉज ऑफ इनएक्टिवेशन ऑफ गेट्स. So inactivation हो गया, then repolarization, potassium channels open, potassium voltage gated. Then what you can see is after hyperpolarization, this is your after hyperpolarization, and यहाँ पे the potassium voltage channels are like they are trying to get closed. ये है after hyperpolarization. This is hyperpolarization, and then return to RMP by leaky channels. Okay, I hope you've got it.